Okay, so this is kind of a take through of how to get the machine started and get the program running, all of that. So first thing you want to do is turn on the instrument. So we'll flip it on a little bit. You should hear it making some sound. It's going to gurgle a little bit, make some uncomfortable noises. There you go. Okay. If it doesn't do that, then it's not working. So you want to listen for those. Then what you want to do is start the program. The program is run by this thing called PerkinElmer UV WinLab. Okay, and so you can double click on that to get it going. Great. And you know you're successful when this science lady shows up. Okay. So we're going to log in as administrator. The software is set up for having multiple logins and keeping track of who does things, which might be important in an industrial setting. We don't really care here. Okay, so click on OK for administrator. Great. Then the software comes about. We can almost see all the software on the video. If you want to see the whole thing, there you go. So this is our entrance screen. And so what we've got here are a list of different techniques or methods. Okay. So if we wanted to determine what the absorbance at 280 nanometers was, we could click on the A280 thing. Let me see if I can zoom in here. We could just click on A280 and that would give us a good start. Okay. If we wanted to do a scan where we were scanning wavelengths and trying to figure out what wavelength something absorbed at, then something that has scan in the title might be a good place to start. Okay, like this was AF488 scan. Okay. If we're doing like a Bradford assay, then there are lots of Bradford assay techniques that are already sort of loaded in. Okay. For you guys, I want you to do a scan. I want you to vary the wavelength and look at absorbance as a function of wavelength. So I'm going to go ahead and click on this AF488 scan, or let's go down to one that is completely blank. So I'm going to scroll down here, and I'm just going to hit scan. How about that? Name scan, type scan, description blank. That's just zoom out. So I clicked on that. It's talking to the instrument. Okay. You may hear some more communication back and forth with the instrument at that point. And now it's good to go. The controls for this are up at the top and the left. Okay. And so if it's live, you're going to see a current wavelength reading and then the absorbance that it's measuring for that wavelength. Okay, so now it's at 650 nanometers or so, and it's not measuring much of it. So let's set up the parameters for our scan. And the way you do that is you go over to the data collection tab. So we're going to click on data collection. And then we have some options. And so right now it's set to scan from 200 nanometers to 700. For the initial experiments that I want you guys to use, let's just stick to visible light. Okay. So we can click this. We can say end at not 200. 200 is too low. Let's pick like 375. Okay. And let's make 700 a little bit bigger. Let's go 750. Something like that. Right? Okay. We can select absorbance or percent transmittance, any of those things. All right. Just stick with absorbance. Split width. We can choose the split width. Remember when we had the thing open yesterday, and there were these slits in there that would vary the amount of light that was given. If you're really struggling for light, make those slits wide. Like if your stuff just doesn't absorb very well, you can make those things wide. Usually I stick to about 1. Okay. Most often with UV vis, like we don't care about things to a super precise degree in terms of the wave. Like usually there's not any difference between 500 nanometers and 501 nanometers. Okay. So having a window that's 1 nanometer wide, doesn't hurt our experiments. Okay. Often there's not much difference between 500 nanometers and 510. Okay. Things are pretty broad. The absorbances are pretty broad, usually. It's not always the case, but usually. All right, so that is just set at 1. I would leave it there. Scan speed, this is set at nanometers per minute, and you can vary that. You can go 7.5 nanometers per minute if you have all afternoon to do a spectrum. You can go up to 2880 if you really don't care about the quality. You're just interested in speed. Okay, so that 480 is kind of in between there. You can play around with that, the speed of all that. Data interval, it's going to take data every nanometer, and it's going to do it once. Okay. Now down here, the lamps, if we're not using UV light for our experiment, we can go ahead and turn the UV light off. So UV lamp off. Visible light we need to have on. And we can change the wavelength where it changes between the two. Okay. All right, so this seems to be good. I like these things. Let's go ahead and I'll pause this video. We'll get a. All right, we're back and we're about to load a sample into the instrument. So I have a glass cuvette, clear sides, cloudy sides, clear side, cloudy side. See, and it's got distilled water in it. So that's my solvent for this one. We've got the camera set up so that this sample holder is in the front of the machine, and this sample holder is in the back of the machine. We want to always use the front one. And so what we're going to do is put our sample into that cuvette holder. Okay. Now the light is coming from over here, and it's going to pass this way through the cuvette and continue on to the detector. Okay. So we want to make sure that our clear sides are the paths that the light is going to. So that looks pretty good. So we can shut our okay, focus back over on the. Awesome. This is definitely cringeworthy. Best video ever. Okay, so now we're back on the computer screen, and if we want to set up doing our experiments, then we can either hit start up at the top, and it will ask us to do what's called an auto zero, or we can go ahead and hit auto zero. There's an auto zero button. Right. Let's go ahead and hit auto zero. Um, so anytime we hit auto 0, it'll go through a little bit of a process. Now, what this is doing is telling the instrument what it looks like when nothing is being absorbed. That's what the auto 0 does. Well, all right, so now we get this message that says remove sample, and then press OK to perform a 100% T correction. Okay. We've always used this in a way that doesn't necessarily follow those directions. So that direction is the proper one if we're always going to use a matched reference cuvette. So you notice how we had two cuvette things in there. If you had one in the front, one in the back, and the back one was always just solid. Okay. So then you take both of them out, run an auto 0. Okay. We're using it a slightly different way, where we just have a sample in the front. So what we want to do is put our cuvette in there with the liquid or the solvent, whatever contains it. Okay, so it's going to feel weird, like you're not obeying the directions, but it's okay. So we're just going to hit OK, and then it'll go through our wavelength range and do an auto 0 correction. So it's doing something. Zoom out, and we can see the process. Zoom out. So if you want to watch the auto 0 perform, then you can kind of follow it up here, and it's going from high wavelength down to low. All right, so it looks like it's done. So now let's run a sample. So I've got a cuvette full of the acid-base indicator thymol blue. I just used the solution that was in the lab and dropped like 6 or 7 drops of thymol blue in and filled the rest up with water. So I don't know what the concentration is, but it'll work for a sample. So we're going to take our blank out, set it aside, someplace safe where it won't fall over, and we'll put our sample in, again, taking care to make sure that the clear sides are facing the beam. And then we can hit start, and it'll collect it. Start. So now it gives us a message that says place the sample in the instrument holder and press OK. So we'll hit OK, and it should be going. There's a little bit of wonkiness with the program, and the wonkiness is that for the first spectrum that you do, it does not show you the data. It's like keeping it a secret, but you can see that the number at the top keeps going down. So it's scrolling through our wavelengths. It's just not telling us what it's seeing. Okay, it will at the end. So you'll get the data at the end, and then for successive measurements after that, it will kind of creep across the screen. It's much more satisfying. So now it gives us our data. So let's take a look at this. All right, so when I look at that data, there's a couple things I want to point out to you. Okay, and what I want to point out to you is that we did not do a very good job. For first experiments, we did okay for first experiments, but overall, not a very good job yet. Here's what I want to point out to you. First, the good stuff. If we scroll down or zoom in here at long wavelengths, doesn't show up on the screen very well, but way over here, it's 750, 700 nanometers. This line looks pretty smooth. Okay, so we've got pretty good signal to noise. Like it's smooth, it's not jaggedy, not jiggling up and down. Okay, that's good. That's what we want. We want to see that. Okay. If we scroll over to where it's absorbing, all right. So if we look at where it's absorbing, you can see that the top of the peak is about 1.2, 1.3, right? That's not really in the sweet spot. Remember, we wanted between 0.1 and 1. Okay, so I would suggest diluting the sample. The most troubling thing about this spectrum is this bump right here and this bump right here. That looks pretty bad. Okay. Now, what's happening here is that most likely we have just not allowed the machine enough time to work. Okay. So especially when light bulbs get old, they take a little while to warm up. You've probably all seen this, like when you walk into a room, especially if you have new LED lights or if you have fluorescent lights, that when you turn the lights on, it's a little dim, and then it just takes a few minutes for it to get up to its final intensity. Right? So what this is telling us, these jiggles here, is that the light was not the same when we did our sample as it was when we did our auto zero. Okay, so if we see this, the solution is let's go back and redo the auto zero. Okay. All right, so I'm gonna pause this so that we don't have. All right, so because that initial data was not very good, it had those bumps right in here. We went back to our blank and we auto zeroed again and ran the sample again, and that cleaned that up. Okay, so you may have to go back and forth several times of auto zeroing and then running your sample in order to get really good data.